Hello, this is Mrs. Workman. Solve the system of inequalities. The first inequality that we're given is y is greater than x. Let's change that just a little bit. Let's write its related equation, y equals x, just till I can start its graph. We notice that this is already in the y equals mx plus b form. The y-intercept is 0, and the slope is 1. So I know the line's going to go through the origin. All right, now let's go back to the original inequality. The original inequality is simply greater than. And so I know that this line is going to be dashed. So I'm going to go up 1 and over 1 and up 1 and over 1 again to get the slope of the line. Alrighty, and this would be the boundary line. Now that line divides the coordinate grid into two regions, so we need to determine which one of these regions contains all of the points whose ordered pairs will satisfy this inequality. So let me pick a point on this side. Let's say this point right here. The coordinates of that point would be -1, 2. So is 2 greater than -1? Yes, it is. And so I know that this is the region that will be shaded. Any point in this region will have coordinates that will satisfy this inequality. Alrighty, let's move to the second inequality, which is 2x plus y is less than or equal to 7. And again, I'm going to box this in just to remind me that that's the original, but I'm going to change it back to its related equation so we can get its graph started. By subtracting 2x from both sides, I can put that equation into the slope-intercept form, and that tells me that the y-intercept is 7 and the slope is -2/1. So if I go on the y-axis 7 units up, 3, 4, 5, 6, 7, and then I go down 2 and right 1 to get the slope or slant of that line, I'm ready now to draw the line. Let's go back to the original inequality. I notice it's less than or equal to, which means now that the equal sign is included, that every point on the line is also to be included in the solution set. And so this is going to be a solid line. So let's draw that in. And again, the line divides the coordinate plane into two regions, and we need to determine which region is shaded. Let's take the origin side, and let's let x be 0 and y be 0, in which case we'd have 2 times 0 is 0 plus 0 is 0, and we would have to ask ourselves, is 0 less than or equal to 7? Well, that's a true inequality, so this is the side that would be shaded. All the points on the red side would have coordinates that would satisfy that second inequality. Now, we were told to solve the system of inequalities. So, in other words, we are looking for all the points in the plane whose coordinates satisfy both of these inequalities at the same time. And so that would be the two regions where the shading overlaps. So it would be this region through here and the points just on this part of the line. Just to make sure that we've done this correctly, why don't we pick a point within this region? How about this one right here? That would be the point with coordinates -1, 1, 2, 3, 4. Okay, I'm going to jot that down up here. -1, 4. And let's run a check. In the first inequality right here, y is 4, x is -1. Is 4 greater than -1? It is, and so we know that that ordered pair satisfies the first inequality. In the second case, let's substitute back into this inequality. X is -1, y is 4, and we're asking ourselves, is that really less than or equal to 7? Well, 2 times -1 is -2, plus 4 is 2, and 2 is less than or equal to 7. So now we have the coordinates of that ordered pair also satisfying the second inequality in the system. So I feel more comfortable saying that every point in this shaded region and the points on this portion of the line will satisfy this system of inequalities.